is electric.
Hi everyone, welcome back for another energy related video. It's the 1st of August and it's time to give you the update for our July statistics, solar and home energy. Well, what a bumper month it's been in July. The sunshine has been great-ish. There's been a fair amount of rain, so it's been really great for the garden. It's been really great for the farmers growing potatoes, but not the best month for solar statistics. So here we go. This is the results from Norfolk for the month of July. Continuing on the weather theme, we have a look at temperatures here. The bottom range there, where it's been peaking just below 15 degrees overnight in the loft. That's showing the outside temperature pretty much. Peaking at the top at more like 25 degrees in the loft and the garage. But the house, that's been keeping nice and steady between 20-21 degrees. And quite naturally too, we haven't had to use heating and only used 49 kilowatt hours of air conditioning this month. The good thing about July though is there's a lot of sunlight. The sun rises early in the morning and sets quite late, and even if it's raining, it doesn't rain the entire day. So we've had a half decent month really. 1,052 kilowatt hours in July, with a maximum day of 55 kilowatt hours and a minimum of just 13 kilowatt hours. But even those 6 days that were under 20 kilowatt hours, 20 kilowatt hours is enough for us. It's enough to run the house. With no heating needed and hardly any air conditioning needed, the only thing we might miss on one of those lower generation days is car charging. The breakdown for that is 519 kilowatt hours from our 3.9 kilowatt solar array with a 3.6 kilowatt Solis inverter. Our latest array, which was 4 panels on the east gable wall and 3 panels over our garage roof, that generated 237 kilowatt hours. And our solar edge array, which is 2.4 kilowatts of solar panels and a 2 kilowatt solar edge inverter, that generated 296 kilowatt hours. Those are south facing as well. If I just look at the solar edge inverter data, so that's the green lines here, then it looks like the second worst July that we've had. But if you look at the darker blue lines, that's the main 3.6 kilowatt array that we have, it's actually in the ballpark. So 1,052 kilowatt hours. It's a lot of generation. I'm very happy with that. And it's not too bad. So July clearly, apart from last year, sometimes rains, sometimes has bad days. It's not too bad a month. This energy chart from Home Assistant is showing the solar generation in the orange that we saw before, and the purple below, that's what we've exported. So it's giving you a good clue that on the duller days we didn't export very much, but on the really sunny days we exported quite a lot. The blue just at the top of the orange, that's where we're importing from the grid. So those days that were more visible, that's when I was charging the car on a windy sunny day. So yeah, we had a little bit of import. I think the most import we had for a single day was 0.9 of a kilowatt hour. Overall for the month of July, just 6.3 kilowatt hours imported from the grid on our Octopus Go tariff. As you can see there, just a couple of days where it crept over the 3/4 of a kilowatt hour, nearly up to 1 kilowatt hour, but most days were under a tenth. Including standing charge, that's going to be a cost of £14.21 this month. Talking of Octopus Energy though, our tariff is coming to an end in the next 4 weeks. So I've got to decide what tariff to move on to. Do I roll over and go with Go again? And the price will go up per kilowatt hour on the cheap rate by another 2 pence from 7.5 pence to 9.5 pence. Or I could go with the Octopus Intelligent tariff where the price is still 7.5 pence on the cheap rate. I could do that. Maybe I should go on the Agile tariff though. There's so many choices. So I'm going to be having a look at those tariffs, including the Flux exporting tariff as well, and have a look and see which one is most appropriate for me. If you haven't already moved to Octopus Energy in the UK, you really ought to think about it. Get yourself a smart meter and get a cheaper tariff. The smart tariffs do work out a lot cheaper. And if you are thinking about moving over to Octopus Energy, don't forget to use a referral code to get an extra £50 credit on your account when you first start up. If you use my code, it's in the description of the video, I get £50 too. Export for the month of July, 431 kilowatt hours, down 140 from last month, but still a healthy number, 431. One day I'll get paid for that export and then it will all make sense as to why I've configured such a large array and we're not using all of the energy. Moving on to where we used the energy that we generated. Well, 85.3 kilowatt hours went to heating our hot water via the Eddy device, and that's in the Mixergy tank. So 85.3 That's just solar energy. There's no boosting, there's no grid usage, there's no other method of heating our hot water other than solar energy that we use through the eddy. In the winter time, when the solar not available, that's when we do boosts and we use grid import to heat the water. But at the moment, it's all for free, it's all from solar energy. Charging our two electric cars, the Volkswagen e-Golf and the Mini Electric, 261.6 kilowatt hours went into those two cars, and I think we drove over 1,500 miles. In fact, that was 1,590 miles for the month in the two electric cars. If we divide that by 50 for 50 miles per gallon, times it by the number of litres to a gallon and times it by the price per litre, that's £210 worth of petrol if we'd had a petrol car that we would have saved by having an electric car and charging on solar for free. And it's this sort of calculation that shows that electric cars really aren't that expensive. I could lease an electric car for £210 a month. And yet that's what I've saved in petrol costs. So by not buying petrol, I'm basically getting the car for free. It's a really good example. Going back to our usage of the energy, this is the view from the My Energy app. I've already said 85 kilowatt hours for heating our hot water, 261 kilowatt hours for charging our electric cars, and 306.8 kilowatt hours is what we used in the home generally for everything, including charging the home storage battery. Looking at another breakdown, this is the Home Assistant view of the breakdown of our energy usage. It's showing the Zapit 258 kilowatt hour usage and the Eddy hot water heating 84 kilowatt hours. The Toshiba units for the air conditioning just 48.67 kilowatt hours, a very similar number surprisingly to our television usage in the lounge, which was 47.57 kilowatt hours. So air conditioning seems like good value to me. Very unusual one here, the bathroom at 41 kilowatt hours. I cannot find out where that came from because I don't recall turning on the bathroom heater. We've got a second fridge as well, only 26 kilowatt hours for that. And the oven and hob, our main source of cooking, just 21 kilowatt hours. Eventually I'll click on that, there we go. I'm really surprised at how little energy we use for cooking, and the electricity we're using just to store the food in a fridge is more than what we're actually using for cooking stuff, and that just surprises me. And the last one on the list there, the microwave usage. I'm going to stop using the smart plug for the microwave soon because it's such a low number. Looking at the data from our Mixergy tank, so that's our hot water tank, we used 2,310 litres of hot water. Approximately. That's quite a lot for us this month. If we look at how full the tank was, this chart is showing a range from 0 to 100% how full of hot water we are. And there's a bit of an anomaly that's occurring in the middle of the month there. One, we ran a big bath and emptied the hot water tank, or almost emptied it, and that's why there was a big drop there. But this also, the coldest water temperature that's being measured, there's a gap in the middle, and it's a little bit odd that I had to investigate this and find out what it was, because with the coldest water temperature would always rise up to the hottest water temperature as we filled the tank. So as we've got lots of solar energy, we should of course every day fill the hot water tank. So when it gets to full at 100%, the cold water section should actually be the same temperature as the hot water section. That's what's happened before. But something's happened there where it's not quite reaching it. And when I contacted Mixergy to find out, they confirmed that there had been a software change and they're trying to implement something where there is a differential between the cold water temperature and the hot water temperature. So they're trying to increase the differential and presumably make it as an efficiency improvement. But that probably works well for people that are using the tank in the digital way, that are using the artificial intelligence that's provided by the Mixergy tank. But for those of us that are relying on the manual thermostat and using the third-party hot water diverter method that they provide, then it looks like it's causing a problem. So I had to report that, and they've backed the software out for me. So I'm back again filling up to 100% while they investigate what's gone on and how they can improve it. To me, this is where the value of data comes in, that I can see this. This data in this chart's not provided by the Mixergy system, but because the data is accessible by an API and because Home Assistant can access it, I can then view and manipulate the data any way I like, and I can see this graph and the problem actually stands out. So data analysis, seeing your data in charts and keeping an eye on it, can show whether you've got a problem or not. If I didn't have this chart and wasn't seeing it, I wouldn't be aware and wouldn't be able to report to Mixergy there was an issue. Home Assistant again, and that's why this chart looks the same. It's the same color and the same look to it, but this is actually the battery state of charge for our home storage battery. So that's our Pylon Tech batteries, 17.5 kilowatt hours of them, connected to our Victron Multiplus 2 inverter. So yeah, most days we're charging up to 100% in the month of July. A couple of days there though, we actually went down to nearly 50%. And on those days, that's where I was giving the car a boost first thing in the morning. So that's showing how much we're using of our battery. Not a lot, most days around 20%. This is the Victron chart that's showing basically the same sort of thing. So the blue band at the top, that's what we're looking at for the battery, and the right hand scale going up to 100%. You can see most days we're getting to around 96%. Remember, I've dialed the battery down, so I've turned the voltage down that we're trying to reach. So once it gets to 51.8 volts, I'm ending the charge. So we're only charging up to 96% as a maximum. As you can see, it's only coming down on most days to around 80% overnight, and just those few days where it dropped down close to 50%. And if you're wondering what all that orange and red is at the bottom, well, it's a bit of a confusing chart because it mixes in solar generation and the amount of consumption of that solar generation as well, all into the one chart. It's a bit busy. I'd rather it was broken down, to be honest, and I don't find the orange and red blocks there very, very descriptive. Update wise, there is a couple of things that I can update you on for the month of July, and the first one is the Zappi. So I've got a Zappi 1, an original one, so I got hold of that in 2018. I wouldn't say I was one of the first customers, but I was an early adopter with it and had the first version of the Zappi. They've now reached the level where in version 5 software, the Zappi 1 isn't actually compatible anymore. So if you want to upgrade to version 5 software and beyond, if you want a Libby battery, etc., then you need to upgrade. So that's what I've done. I've now gone ahead and got a Zappi 2 charger to install. The great thing about that is got the Wi-Fi hub integrated, so Wi-Fi is integrated. It's a simpler, slicker looking solution. I actually like the look of the Zappi 2 more than the Zappi 1 as well. So yeah, I've taken the plunge and got a Zappi 2. I just need to get it installed, and I don't know whether I can do that myself or not. Physically, wiring wise, I'm pretty certain I can, but whether I want to, I'll work that out later. Maybe I'll wait for when there's an electrician on site. The other thing, I think I mentioned before, EcoFlow obviously liked what I did with their PowerStream product, and they've sent me over a Delta 2 Max to try. So I'll be trying that portable battery out. And it's this size of battery, and I do say size because the Delta 2 Max is a big chunky thing. It's twice the capacity of the Delta 2. It's 2 kilowatt hours of battery capacity, but the power output is more than 2.5 kilowatts continuously, and with X-Boost it's even more. So with that battery capacity of 2 kilowatt hours and some solar panels on it as well, it's enough to charge the car. So I'm going to be testing that. I'm going to be testing charging both our electric cars using the EcoFlow battery to see how many miles I can add from that battery. And especially on a sunny day with some solar panels, if I can get more than 2 kilowatt hours into the car, that should be 10 miles. 10 miles of range from a battery that goes in the boot of the car is pretty handy, especially if I do some tests on the cars that I have for running out of fuel and seeing how they perform. I wouldn't really want to do that unless I'm confident I can charge the thing back up. That's it for July. Thank you so much for watching. I hope you enjoyed the video, and I hope there's some good statistics for you there to compare to your own or to encourage you to go solar and battery. Don't forget to leave me some comments. How are you getting on? What are you thinking? Are you planning any changes on your system? Love to hear your comments. It's a great thriving community. So take care. See you again soon for more videos. Bye for now.